All right, in linear programming problems, the objective function is just the function that we're trying to maximize or minimize. So far we've just been solving two variable linear programming problems. These are problems that we're given the objective function and we are given a list of linear inequalities that the variables have to satisfy, and then we try to find the choice of those variables that will not only satisfy all the constraints or the inequalities, but at the same time give us the either maximum or minimum value of the objective function. At this point in the course now we're going to focus on modeling and word problems. So given some realistic problem, we want to translate some given information, which is not always organized in the best way possible, and we have to organize it into a math problem or a linear programming problem. So we have to define the variables. We have to give a formula for the objective function. We have to decide, are we maximizing or minimizing it? And then we will have to come up with a list of all the linear inequalities that the variables have to satisfy. In this module, all we're focusing on is identifying the variables so that we can define the objective function. So basically start off with just identify the quantity z to be optimized. This is going to be like a profit if we want to maximize profit, or a cost if we want to minimize cost, but it could be one of many different things that we could try to maximize and minimize. Z is just a label I'm using for this total quantity that we want to optimize. Then we need to define all the decision variables. Again, the problems we've looked at so far have had two variables, but we could have problems with many variables. So I'm just giving kind of general way of using subscripted letters here, x1, x2, all the way up to some x sub n, where those are the variables we need for a given problem. So the number of variables will vary from problem to problem. The two variable problems we can solve graphically, but there are ways that we will find to solve these problems non-graphically because we can't draw pictures in with higher number of variables. So what are the decision variables? Really, these are values that are needed to compute the value of z. But they have values that we don't know. That's why they're variables. The values we want are the values that we have to determine. We want to determine the values of these that are going to obtain our objective of maximizing or minimizing z. But in order to do this, each of these variable quantities is tied to some fixed value per unit, which I'm just calling c with a subscript 1, 2, 3, and so on. So that multiplying the number of units x subscript I by the value per unit c sub I will give us a total value contributed from that quantity x sub I. So the important thing here is that the value here is some unit of measure that is representing z. A lot of times in these problems that are in business, we're talking about dollars, but it's not always the case. So if it were dollars, then x sub I could be the number of units of some product that we want to decide on how many to make, and c sub I could be the profit per unit for that kind of product. So multiplying those numbers together gives us the portion of our profit, z, which comes from that specific product. So to define the objective function, we just decide whether or not we have to maximize or minimize. Once we make that decision, we write down how is the value of z computed in terms of the values of the decision variables and the values of their corresponding value per unit. And it's always going to look something like this. Just the number of variables will change from problem to problem. So again, you have to choose whether this is a maximize problem or minimize problem. So when you do that, you will write maximize or minimize in front of the objective function just as a label to let the reader know what kind of problem we're dealing with. You're not going to write maximize slash minimize. I'm just putting that there to emphasize that there's a choice that needs to be made. So this objective function, which is z, so z is a function of the variables x1, x2, and so on. And the numbers c1, c2 are like coefficients that are known numbers. So again, this is the function that is to be optimized by some decision of the values of x1 through xn. That's why they're called decision variables. We want to basically do the math without knowing the solution to figure out what those values need to be. But in the end, remember, we're talking about realistic problems, so whatever quantities are, they are tied to some unit of measure. It could be dollars, it could be some measurements like length, it could be some measurements like dollars per foot. You have to tie all those things together. What I mean by that is you need to make sure the units of each term, c sub I, x sub I, match the units of z. If z is in dollars, then every term that we see in this equation has to be in dollars too. So you can't compare apples and oranges. So you can't have dollars on one side and have some other units on the other. It doesn't make sense. A lot of times this is pretty clear, but sometimes it takes a little effort to decode the word problem to make this make sense. So let's look at a first example of this. This is a typical problem. This only has two variables, a production mix, and this is for a lumber company. So we'll just read through the problem first. And for now, we're really just focusing on the objective function. So most of this information we're not going to use right now. We'll use it later when we actually finish creating the entire model. But for now, we just want to identify what the objective function is. So a lumber mill saws both finished grade and construction grade boards from the logs it receives. All right, suppose each 1,000 board feet of finished grade needs 2 hours to rough saw and 5 hours to plane. Suppose that each 1,000 board feet of construction grade needs 2 hours to rough saw and 3 hours to plane. The saw is available for 8 hours per day, and the plane is available for 15 hours per day. If the profit for 1,000 board feet is $120 for the finished grade and $100 for the construction grade, how many of each type of lumber should be sawed to maximize profit? So we're just giving a quick read through to identify the obvious thing. Our goal or objective is to maximize profit. It's spelled out for us. All right, so we definitely want to do that. And generally things are given to us in dollars, so we're going to maximize profit in dollars. There are problems when some of the monetary things are given to you in dollars and some may be given to you in cents. If that happens, you have to decide which unit you're going to use. And depending on which choice you make, that's going to change what your formulas look like and your inequalities are going to look like. So going back to this information, how do we get profit? Well, what do they sell? They sell different kinds of lumber. And there's two described here. If the profit for 1,000 board feet is $120 for the finished grade and $1,000 for the construction grade, that's telling us exactly how many variables we have and what they mean, and how much profit we get for each of those. So since we have two variables, one is for a type of lumber called finished grade, and one is for a type of lumber called construction grade. Those represent our variables, so you need to write down a sentence defining each of these. So we say, let's let x1, our first variable, is the number of 1,000 board feet of finished grade lumber to saw. Notice I included the units here. The units are 1,000 board feet. So every 1,000 feet of this lumber that is cut is considered a single unit that they're going to measure things by. And the reason we're using that unit is because the profit per unit for this was $120 for each of those 1,000 board feet. And then again, x2, the second variable, is just the number of 1,000 board feet of the construction grade lumber to saw. Again, be specific, write a complete sentence which tells the reader exactly what the variable is representing, what the units of that variable are, so that we can understand and make sense of what the objective function is. So in this case, we want to maximize profit. So z of just profit. That's what we're maximizing. So you can name it. If you want to go ahead and call it z still, just somewhere else, you would write z is the profit or total profit. So how do we get profit? We get profit from selling two types of things. So we have two terms. $120 per 1,000 board feet of the finished grade times the number of 1,000 board feet of finished grade will give us a dollar amount. To that we have to add $100 per 1,000 units of board feet of the construction grade times the number of thousands of units of board feet, or thousands of board feet of that construction grade. Very simple, pretty straightforward. So that's kind of the basic example. But again, this first step of just identifying the variables so that you can write down an explicit function or formula for what you're trying to optimize is crucial. If you mess this up, it really doesn't matter what else you do in the problem because nothing's going to make sense. So you really got to focus on getting your units to match up so that when you plug in numbers for x1 and x2, that number you get after you compute is a number of units that's the same as what you're trying to maximize, in this case dollars.